Hello everyone, Kotungwane, the native code here. Today I'll be taking you through question 1 of the exam Engineering Science N3, which was written on the 31st of March 2023. Right, now question 1 was based on the module Motion, Power and Energy. Right, let's get right into it. 1.1, define the acceleration of an object. Now whenever you're dealing with a problem based on motion graphs, we have to consider the following triangles. Right? Now, the green triangle is based on the displacement time graph as well as the velocity time graph. And then the blue triangle is based on the velocity time graph as well as the acceleration time graph. Now, whenever you're dealing with a problem where you can use a triangle with variables inside of it, the variable on the left of that triangle, whichever triangle it may be, the variable on the left you can always define using the formula, right? The formula, what do I mean by that? Say for instance the triangle on the left, so the green triangle, if you want to calculate velocity, right? Velocity is going to be equal to what? Velocity is going to be equal to a change in displacement over what? Over time, right? Similarly with the one on the left, right? The one on the left, if you wanted to calculate the variable on the left of this triangle, variable on the left of this triangle is what? Is acceleration, right? Is acceleration. So acceleration is equal to what? Acceleration is equal to a change in velocity over what? Over time. Now, like I said earlier, is that the variables on the left can always be defined using those very formulas. Now, what do we mean by this? Right, going back to the one on the left, velocity, right, is equal to what? A change in displacement over time. Now, if you wanted to define a velocity, you would use that very formula. So you would define the velocity as what? As the rate of change of what? Of displacement. Similarly with acceleration, which is what we're looking for. Acceleration is equal to what? Acceleration is equal to the change in velocity over time, right? So similarly, you would use that very formula to define acceleration. Acceleration is equal to what? The rate of change of what? Of velocity. So acceleration put into words is equal to what? Is equal to, or is, acceleration is the rate of change of what? Of velocity. Now you obviously do not have to jump through all these hoops just to define acceleration, but I'm just showing you how easy it is to define the likes of velocity and acceleration or any other variable that would be on the left of any triangle, right? Now, moving on to question 1.2, right? Question 1.2. All right, let's see what we have. Question 1.2 reads as follows. The graph in figure 1 shows the velocity time relationship of a free falling object from t is equal to 0 seconds to t is equal to 4 seconds. Use the graph to determine the following. Now, before we get to that, right, so if you look at figure 1, it is a velocity time graph. Now, what do we know about a velocity time graph? This here is a typical velocity time graph, right? We use this velocity time graph to derive all of our kinematic equations, otherwise known as equations of motion, right? So you would have the initial velocity from 0 to u, that's your initial velocity, right? And then from 0 to v would be your final velocity, right? So what is v equal to? V will be equal to what? U plus what? Plus at. Now at, the orange part, right? Whenever you get a change in velocity, right? Whenever we get a change in velocity, what do we get? Remember from this triangle right here, right? First remove this and that. From this triangle, right? The change in velocity. So if we wanted the change in velocity, the change in velocity will be equal to what? Will be equal to acceleration times what? Times, so this will be equal to what? A times t. So acceleration times time, right? So meaning whenever we get a change in velocity, right, we experience acceleration, right? Whether that's acceleration or deceleration. If you get a change in velocity, we experience acceleration. So in this graph where we see the parts where the velocity changes, that's where we experience acceleration. Hence, the orange part of this graph is what is the change in velocity. And what is the change in velocity? Again, the change in velocity is equal to what? Is equal to a times t, right? Hence, you see the orange part is named at, right? So the change in velocity is equal to what? Is equal to t, is equal to at, meaning v is going to be equal to what? Is equal to u plus at, right? That is a typical problem based on a velocity time graph, right? So whenever we need to derive our kinematic equations or equations of motion, this is the graph we would use to derive them, right? Now, if we look at figure 1, right? Figure 1 is very similar to this graph, right? The only difference is that in figure 1, v is named m, right? So m in figure 1 we will take as our final velocity, right? Also, the acceleration, since this is free falling, right? Since this is free falling, the acceleration we will use as what? As gravitational acceleration. Now, what do we mean by that? If we were to represent figure 1 similarly as how we represented the velocity time graph, which we used to derive our kinematic equations, this is what we will get. So first, let's remove this. Let's remove this, right? And then to represent figure 1, this is how we do it. Right? So we have 0 here, right? So we have 0, from 0 to 16, that's our what? That's our initial velocity, right? And then from 0 to m is our final velocity, but our final velocity is represented by m in this case, right? Meaning what? Meaning m being our final velocity will be equal to what? Will be equal to u plus what? Plus gt. Remember, this time around, because the object is free falling, our acceleration will be used as a gravitational acceleration, right? Now let's go back to the question. Question 1.2.1. So use the graph to determine the value of m. Right, so we're going to use this graph to determine the value of m. Right, this is 1.2.1. Right, 1.2.1, again we need to determine the value of m. So value of m, as we have established, m represents the final velocity, right? And the final velocity is equal to what? Is equal to u plus gt, right? Now u being the initial velocity we have, and it's what? It's 16 meters per second, right? And then gt, we also have t being what? Being 4 seconds, and g, as we know, is 9.8. So m is equal to what? U plus gt, right? So m is equal to u is 16 meters per second plus g is 9.8, and then t is what? 4 seconds, right? So if you punch this in the calculators, you would get 55.2 meters per second, right? This is 2 marks, very easy, right? So let's move on to 1.2.2. Right, 1.2.2 reads as follows. We need to determine the displacement of the object after 4 seconds, right? We need to determine the displacement of the object after 4 seconds. Now, there's a few ways you can do this, right? Remember, they said from the graph. So whatever formula you use, it has to be from the graph. Now, from the graph, if they say from the graph, you need to use the area under the graph, right? Now, if we use the area under the graph, right, we are going to use area under the graph as being what? As being area of a trapezoid. Now, if you want to know why we use the area of a trapezoid, you can subscribe to this channel, and then I'll be doing lessons covering all the modules in engineering science N3. And in those lessons, in that playlist, that's where you will get to discover why and how we use, in this typical problem, how or why we use the area of a trapezoid, or how we can use the area of a trapezoid. Right? So we're going to use area under the graph, since they told us to determine everything from the graph. Right? So we use area of a trapezoid, and if you use area of a trapezoid, S, which is the displacement, is going to be equal to what? V plus U over 2 times T, right? So S is equal to the final velocity, right? Remember, the final velocity here is represented by M. So M we found to be what? 55.2 meters per second. So this would be 55.2 plus the initial velocity, which is what? 16. So initial velocity is 16 meters per second. So 16 over 2 times t, which is what? 4 seconds. Now if you punch this in your calculator, you are going to get 142.4 meters, right? This is 3 marks, easy 3 marks, right? The easiest 3 marks you're probably gonna get in any test or exam, right? Hope that was clear. Now we move on to 1.3. Now 1.3 reads as follows. A Toyota Yaris weighing 3.5 tons is driven uniformly from a stationary position to a speed of 72 kilometers per hour during a period of 25 seconds on a horizontal road. Assume that the resistance against motion is 0.1 newtons per kg, right? And they say calculate the total force exerted by the Toyota Yaris. And the second question is calculate the change in momentum of the Toyota Yaris. Okay. First, let's look at what we've been given here, right? So let's draw a free body diagram, right? If you draw a free body diagram, it's gonna look like this. Right, your free body diagram is going to look like this one, right? So you have an object, they said it is 3.5 tons, right? So Toyota Yaris is 3.5 tons. 3.5 tons converted to kgs is 3,500 kgs, right? And they said it's driven uniformly from a stationary position, right? So from a stationary position, meaning what? Meaning u is equal to 0, right? So your initial velocity is 0, right? To a speed of 72 kilometers per hour, right? Now, as you know, velocity has to be in what? In meters per second. So we convert the 72 kilometers per hour to what? To meters per second. And this is what we get, 20 meters per second, right? And then, of course, the time or the period is what? Is 25 seconds, right, on a horizontal road. Now, they say assume the resistance against motion is 0.1 newtons per kg, right? What does that mean? Resistance, we know, is what? It is the frictional force, right? The frictional force is equal to 0.1 newtons per kg. So this is 0.1 newtons per kg. So to get this into newtons, we need to multiply by the what? By the mass of the Toyota Yaris. Now the mass of the Toyota Yaris is 3,500, right? Kgs. So this and that goes, and you only left with what? With newtons. 0.1 times 3,500 is equal to what? It is equal to 350 newtons, right? So the frictional force is equal to what? Is equal to 350 newtons, right? Now, obviously this object is in motion, meaning there was a force that was applied, right? The force being applied being what? Being Ft, right? Ft or F sub t, we know is the total force applied, right? And whenever an object is moving in any direction opposing the motion, you get what? You get the frictional force, right? You get the frictional force, right? Now, because this is moving in the direction of what? Of the force applied, we know that acceleration is in the same direction as what? As the force being applied. What does that mean? This means that F sub t is greater than what? Is greater than F mu, right? Therefore, as far as the vector sum of forces, the vector sum of forces being what? Being F net is equal to what? Is equal to F sub t minus F mu, right? Now, if you want to know more about how we get to these steps, again, subscribe to the channel. And like I said earlier, I'll be taking you through all the modules, right? And all the steps we take to simplify any complex problem or any complex condition or any complex ideas or any complex principles, right? But because this is just based on what we did for the exam, I'm going to be handing out little details, right? So F net being the vector sum of forces or the resultant force is equal to what? F sub t minus F mu. right? Now, let's look at question 1.1.3, 1.3.1, sorry. So we have 1.3.1, right? Now 1.3.1, they say calculate the total force exerted by the Toyota Yaris. They're looking for the total force, F sub T, right? Now, going back to this here, right? F net is equal to F sub T minus F mu, right? Now, what are we looking for? We're looking for the total force. We are looking for the total force exerted, which is what? The total force is what? F sub T. So we are looking for F sub T. We have F mu, but we do not have F net, right? But we can get F net. Now there's two ways we can get F net, or there is a number of ways we can get F net, right? But the one we are going to use is based on what? Is based on Newton's second law of motion, right? Newton's second law of motion, or from Newton's second law of motion, we know that F net is equal to what? Is equal to ma, right? We have the mass of the object. We don't have the acceleration of the object, but we can get the acceleration of the object, right? Remember, acceleration, what is it equal to? Acceleration is equal to what? A change in velocity. So v minus u, right? Over what? Over time. So acceleration is equal to what? Acceleration is equal to final velocity is 20 meters per second. So 20 minus the initial velocity, which is what? Which is 0, because the Yaris started moving from what? From a stationary position over the time t, t being equal to what? 25 seconds. Right, so if you punch this in, we are going to get 0.8 meters per second squared, right? So from this formula, we have the mass, and now we have acceleration, so we can get F net. So F net is equal to what? Mass, which is 3,500, times what? Times the acceleration, which is 0.8. F net is equal to what? If you punch this in, we're going to get 2,800 newtons, right? Now, as we established earlier, that F net in this case is equal to what? Is equal to F sub T minus F mu, right? Now we have F net and we have F mu, so we can get Ft. So F sub T, you take F mu and you get it to the other side, Ft will be equal to what? F net plus F mu. This will be equal to what? 2,800 plus F mu, which is equal to what? 350. Right, and then if you punch that in, we are going to get 3,150 newtons, 3,150 newtons. Right, that is question 1.3.4. Right, easy. Question 1.3.2. Right, they want us to calculate the change in momentum of the Toyota Yaris. Right, now whenever you're looking for a change in momentum, right, whenever you're looking for the change in momentum, you can always consider this triangle. Right, you can always consider this triangle. Right, you can always consider this triangle. Right, so again, the variable on the left being what? Being F net can be defined using the formula. right, which we get on the triangle. The formula being what? The formula being F net is equal to what? Is equal to the change in momentum over what? Over the time, right? But now we are not looking for F net. We are looking for the change in momentum, right? So the change in momentum is going to be equal to what? Is going to be equal to F net times the time, right? F net times the time. Now, F net, we have it as well as the time. Meaning what? Meaning to calculate the change in P. So change in P is going to be equal to what? Change in P. Change in P is going to be equal to what? F net times what? Times T. So F net times T, right? So change in P is going to be equal to what? F net we calculated earlier and we got 2,800 times the time. The time, if you go back to the statement, the time is what? 25 seconds. Times 25. So this will be equal to what? If you punch this in, we are going to get 70,000. So 70,000 kgs meters. So momentum is kg meter per second, right? That is 1.3.2. Easy. Now there are other ways you could have calculated the change in momentum, but the quickest way of getting anything is by using what you've been given or by using what you've calculated, right? Always try to take the path of least resistance, right? And as far as change in momentum, this would have been the path of least resistance, right? So now we go to question 1.4. Right. Now 1.4 reads as follows. A pulley is driven by a driving belt with a speed of 12 meters per second. Right. The tension in the slack side is half the tension in the tight side. The tension in the tight side is 800 newtons. Calculate the tension in the slack side as well as the power transmitted. Right. Now let's see what we have here. Right. This is what we have. Right. So you have two pulleys, right? The one driving the other, right? So meaning this one driving this one, right? So on this side of the belt, we're gonna have the tight side, and the tight side they said the tension in the tight side is 800 newtons, right? And that the tension in the slack side is what? Is half the tension on the tight side. So meaning T2 is equal to half of T1, right? It is important to always try and draw or show a visual depiction of what is in the problem, right? So we look at 1.4.1. 1.4.1. Right. Now 1.411, they say calculate the tension in the slack side. Right. This one is pretty straightforward. They've already told us that T2 which is the tension on the slack side, is equal to what? Is half the tension on the tight side. So it's half of T1, right? We've been given T1, so we can get T2. So this will be half times T1 is equal to 800 newtons, right? So if you punch that in your calculator, you get 400 newtons, right? Pretty straightforward. And then 1.4.2 right? So actually okay, right. So 1.4.2, calculate the power transmitted. Now, as you know, power is equal to what? The effective tension times the circumference velocity, right? The circumferential velocity. Now, the circumferential velocity they've already given us. They said a pulley is driven by a driving belt with a speed of 12 meters per second, right? That 12 meters per second is your circumferential velocity, right? What we do not have yet is the effective tension, but the effective tension we know is equal to what? T1 minus T2. So times V, and we have both T1 and T2 now, right? T1 is 800 minus T2, which we calculated as being 400, right? Times the circumferential velocity, which they gave us as 12 meters per second, right? Now if you punch this in your calculators, we get 4,800 watts, right? And that is it as far as question 1, right? So again, if you want to know more about the conditions, the principles, the ideas that have been applied on module 1, follow the channel and hit the notification button, for all the episodes I'm going to post, or for all the videos I'm going to post regarding engineering science N3. There will be a playlist which will have all the modules we cover in engineering science N3, right? I hope this has been helpful to you. All the best to everyone. Goodbye.